James Webb Space Telescope is the largest telescope ever built that is going into space. I would say it's a successor to Hubble rather than a replacement, but it's going to give us a tremendous new window on the universe. James Webb has been designed in particular to look back into the very beginnings of the universe. Light from the early part of the universe is shifted into the red part of the spectrum. So James Webb is optimized to work in those wavelengths. And it will be able to look back to the first stars and the first galaxies forming very soon after the Big Bang took place. So this is a mock-up of one of the segments of the James Webb Space Telescope mirror. It can be individually adjusted to get the perfect focus for the James Webb Space Telescope. But they have to be folded up for launch. And so the whole telescope has a central panel and then two wings which unfold once the telescope is in orbit. Then you collect the light through the mirrors, focus it onto what we call the secondary mirror. And the secondary mirror, which is sticking out a few meters away from the primary, directs the light back into the instruments that we use to record the images and the spectra. So it's not enough just to have a large mirror to collect the light. You have to have a set of instruments to actually record the light that comes through the telescope. The university has been involved in one of the key instruments called the Mid-Infrared Imager, or MIRI for short. And we were involved in the engineering design of that particular instrument and have been supporting the manufacture and testing of MIRI all the way through to when it was integrated into the telescope. Because James Webb works in the infrared, we want to keep it as cool as possible because there's a lot of infrared radiation in space that can warm it up and make it less sensitive than it needs to be. So we're going to fly James Webb to a place called L2, which is actually in orbit around the sun rather than around the Earth. The reason we go out that far is that the telescope can be shielded from the sun. It's away from a lot of radio interference that can be generated by the Earth, as well as the Earth's own infrared radiation. And that's about 1 million miles away from the Earth. And it'll take about 30 days to get there. And during that time, we'll actually start to open the telescope up. So we'll be doing a lot of work on the journey, and by the time we get to L2, the telescope should be fully ready to start observations. Unfortunately, James Webb is so far away from the Earth that at the moment there isn't much prospect of astronauts being sent out to either repair it or to replace any of the instruments. So everything has to work perfectly, and we're going to be watching very carefully as all those operations happen, particularly unfolding the protective shield, then opening up the mirror, and then finally deploying the secondary mirror that directs the light into the instruments. One of the great mysteries is how the first stars formed and then how they collected together to form galaxies and eventually build up into galaxies like the one that we live in. So we can study the nearby universe and we can learn a lot about the structures of the universe as they exist now. But we expect that James Webb will tell us about the very early history, how those structures actually came to be, and in the end, how we came to be part of the universe. So because we've been involved in developing the mission, we actually have some time on the telescope, which is what we call guaranteed time for the people who actually help build it. And so some of the researchers at the University of Leicester are really getting themselves ready to actually use James Webb once it's in space. One of the particular things that's of interest to people in Leicester is to study the planets in the outer part of the solar system, particularly the gas giants like Jupiter and Saturn, but also what we call the ice giants, that's Neptune and Uranus, that are particularly fascinating because we don't know that much about them. And James Webb will give us a new opportunity to study them in detail. For a long time, the only planets we knew about were those that are in our own solar system. But in the last 15 or 20 years, astronomers have actually discovered lots of planets orbiting other stars in our galaxy. We call those exoplanets because they're outside the solar system. James Webb is going to be a very powerful instrument for studying those, particularly the giant planets that look a bit like Jupiter or Saturn, because they're very bright in the infrared compared to small planets like Earth. We don't know that much about those because we've not been able to observe them directly. And James Webb will give us an opportunity to study more about their atmospheres and about their physical structure, which will give us great insight into how planets are formed in general. James Webb is an important telescope because it's the next great advance in astronomical science. Astronomers are always trying to probe further and deeper into the universe or understand smaller, fainter objects. It's all about where human understanding is going. Every time we launch a brand new telescope into space, we always learn something new. James Webb is such a large telescope that it's really going to transform our knowledge about a lot of things. So it's very important that the investment that we've made is successful. It costs quite a lot of money to build the James Webb, and it's important to think about where that money goes for a start. It's $10 billion, which seems like a very, very large amount. But what we have to remember is that that money is not spent in space, it's spent here on Earth. It's spent paying people to work on the telescope. It goes into companies that work in the space business, and those companies spend money in the locations where they're based. So the money actually goes through into the economy in the end and actually supports high-tech businesses, which is something that we actually need in this century as we go forward. We need lots of good employment for people. And the space business is a good way of generating that. The other aspect is that people are very inspired by studying the universe. It's really interesting to me that it's one of the things that people are most interested in next to dinosaurs. It's why we have the National Space Centre in Leicester, to convey that excitement to everybody and give everybody an opportunity to share in something that used to be just confined to the scientists who are involved in these missions. And I think there's very important messages there for people to understand what it means to be in the universe, and to take that inspiration and excitement into encouraging people into education, particularly into science subjects, which we need for economic reasons as much as anything. James Webb is a lot bigger than Hubble, and that's one of the reasons that we want to put it into space now, because we want to probe into the distant universe more effectively than Hubble has been able to do. So size is one thing, and the other thing is the infrared wavelengths that it can study. Hubble is a great instrument, and it's had 30 or more years in space, giving us ultraviolet, visible light images, as well as a little part of the infrared. But Hubble cannot see the longer wavelengths of infrared that are the key to understanding the early history of the universe.